Okay, so I did talk on Siril before, on processing with Siril, but it was in conjunction also with Photoshop and later Lightroom, But today I will so you should know more or less basics of Siril, how it works. So today I will just concentrate on what was added to Siril. It was few quite powerful tools added, which make this more standalone software now. But I still would recommend to finishing touches to making some specialized editing software like Photoshop, Lightroom, or similar ones. There is plenty, or even free GIMP and stuff. So, but the most important work in deep sky photography is just stretching picture, and now Siril has new tool, powerful tool for stretching, and plus other tools. So that would be main workhouse, and any finishing touches in other software would be just cosmetic. But I still would recommend, if you've got any software to finish off later, then you should do that. But for today I will just concentrate mainly on Siril, and that's where all processing will stop. I will not go like last time to other software to finish it off. Okay, so when I did my talk, Siril version was 1.0, but together with Siril version 1.2, this is the newest version, which was a few weeks ago, 1.1. But in version 1.2 there was few powerful tools added. Among others was added what is called Starnet was integrated, is now integrated. If you remember what we did before, we did processing in Siril and stretching, and then we exported picture to 16-bit TIFF, and then we used Starnet as standalone software to separate stars from any nebulosity, and then we went to Photoshop to edit further nebulosity and minimize stars, because stars were already stretched and were really large, because we couldn't stretch them when the picture was linear. So that was the only way to do that. Now, because Starnet is integrated, so we can basically separate stars when they are when picture is linear, so stars are almost not stretched. Software will pre-stretch them slightly in order to separate them, but there will be just minimal stretch. So I will show you anyway. So that was the implementation. Starnet into the Siril was first, and was really good move, because that give us more opportunities, especially with controlling stars and separating stars from the rest of the picture at the early stages of the processing. And other very powerful tool is generalized hyperbolic stretch transformation. So those are two main updates which were in this version 1.2, which gave a lot of opportunities. Also there was smaller updates like deconvolution. Deconvolution is basically this is mathematical algorithms which will look at your picture and will try guess how atmosphere smear your picture, and it will try reverse this process mathematically. So the best is do this using stars, because stars are points of light, and software know that should be points of stars, and it will analyze shapes. So this is basically the convolution will sharpen your picture, will be a bit sharper because it got smeared out by if it's bad seeing and stuff. Also, if you've got bad tracking, maybe it was wind and something, and your mount didn't track, and your stars are slightly oblong, also using the convolution slightly will improve stars, and so this is another function added. and something else was added. Those basically were, and also noise reduction was added, but it's not very impressive. We will use it, I will show you how to use it, one of this, what I think is best, but you know, it's still, noise reduction, it's not very good here. And also, as at the beginning, always I show you that first of what we should do was do background extraction. So in Siril before was only one approximation method for background extraction. Now it was also added one more method, which is especially useful, that doesn't require as much sampling points, which is useful when you've got picture where is a lot of nebulosity, because those sampling points always need to be on the background, on the sky. So if you've got, for example, something like, you know, what I shot, Elephant Trunk Nebula, which basically whole picture is nebulosity, it's not much background there. So it's better to use this new method, which I'll show you in a second. But first of all, I will show you, if you cannot remember, if you don't have Siril or want to update, you can just go to Google and just type Siril, and then you should find first result at the top should be Siril, so just click on that, and then whatever is your operating system, most of you will have Windows, and most of you will have Windows 10 or higher, which is 64-bit. Then you can just click this, and this will download, you know, installation file, and then you can install this as well. But what I told you is that now Starnet is incorporated, but it's not included with Siril, so we still need to install Starnet separately and show Siril where the file with Starnet is. So what I will do, I will open picture, because otherwise I cannot show you. So if I will go to start processing, and I will get Starnet star removal, what you will see in a second is here you've got a message, valid Starnet v2 executable found in the configured Starnet installation directory. That means that, you know, that my Siril knows where the Starnet is. So because I already told it, so I will show you how to do this, how to connect them together first. So first of all, you would download Siril. After you download and install Siril, just the same, use Google and type Starnet, and then at the very top you will have Starnet. Just click on this page and then click here download, and then you will have different versions. So it will be for software called Picking Site, which is specialized software, and for Windows Picking Site, and so on. We need to go and find Windows, and what we need to do is download this file. This is just zip files. So that means that all files are there packed inside. So if you click this, you will see that it will start downloading. Mine doesn't downloading because, oh yeah, it's downloading here. Anyway, I've got this installed. I'm just showing you it will. I will wait maybe a second, and then after it's download, you need to unpack it somewhere. What I normally do, because this doesn't require installation, so if you click on this after it's downloaded, so you can go just inside. Sorry, yeah, you are inside downloads. So just you can go copy this, all this folder, and then, you know, and then you can, the best is if you've got, you know, some software folder. I've got, you know, on my computer, I've got what I've got special directory when I've got Astro software. If you don't have any, what you can do, you can just click right Okay, not here, sorry. Anyway, you will need to unpack it somewhere, and you need to know where it is, what is, you know, path. Say what I will do, maybe I will click here, and I will go. You can see all my hard drives. I've got, you know, on X hard drive I've got folder Astro, and I've got here Astro programs, and this is where I, you know, all my Astro software lives, which doesn't require installation, because some software like Siril will install actually, so you don't need to keep it here. As you can see, I just added here what this is, this folder. If you don't have a folder, you can just create one. Just click write new folder, and then you can Astro software, whatever, and then you go inside and just right click and just paste, and you can see now it's unpacking. So this is Starnet now, and you can see this is this file which Siri will be looking for. So after you install that, unpacked basically, not install, after you download that, you unpacked somewhere on your computer or there on desktop. If you don't know where, then the best unpack on desktop if you don't know structure of the files in the computer. So after it's installed, we can go back to Siril, and now we just need to tell Siril where the Starnet is. So we need to click this hamburger option, and then preferences, and then at the very bottom is miscellaneous, and then you will have here software location, and here you've got comment must point to valid Starnet executable. So you just click on that. You can see that mine is already there, and in my case I've got X Astro programs, and then I would click here and here open, and that everything you need to do. Now your Siri know where the Starnet is, and every time when you want to process stars, it will do that. If it will not work, that's mean that, you know, something is not correct, and you need to tell it again. But basically, when you Starnet, first of all, in this window you can check if Siril is seeing Starnet or not, because if we will be not seeing it, then this will be valid Starnet v2 executable, sorry, is not available or something like that. That you will know from that message here. In my case, you can see that Siril can actually see where the Starnet is, and you know, this is basically what you need to do to have Starnet inside Siril. So basically, install Siril, download and unpack Starnet, and tell Siril where you unpacked Starnet, and that's it. And you are ready to use it inside. So before, if you remember, because Starnet cannot use fits files or 32-bit files, we needed to save, you know, first save fit from Siril into the 16-bit TIFF, then open this in Starnet, and then, you know, if you wanted to do something in Siril, you needed to convert this back to fit, 32-bit fit. Now when you do this, Siril will do this for you automatically, everything. So if picture is linear, it will press stretch slightly, then it will create TIFF, export it to Starnet. Starnet will process, and Siril will convert automatically both stars and background into 32 fits file and open them. It will open background in Siril, so everything is automatic. You don't need to, you know, bother with, you know, transforming files and converting them and stuff. Okay, so after we've got prepared, all software prepared, then now I will show you maybe another. So this is basically, I will just quick reminder that if you want to work with pictures in Siril, then you need to tell Siril where is your root directory, where is your working directory for the picture. So basically you need to click here, and like for me, I've got just this in special folder prepared for Deep Sky Object Talk. And so anyway, whatever, my normal pictures are here in Astro, and I've got all those nebulas and stuff. But for today, I've got just different stuff. Okay, anyway, just to reminder, because if you will try to do anything, then all files will be Siril will try to read and write to this directory, which is your home directory. So first of all, just tell Siril where your files are with picture. As again, I've got already stacked picture. You can stack picture either in Deep Sky Stacker or here in Siril. My plan was to show you options in Siril for stacking in scripts. They are scripts, so you don't need to know what to do unless you know how to prepare. But as I said, my voice may be not very good today, so if I will be in shape enough, then at the end maybe I will go back and show you how to stack pictures in Siril using scripts. But for now, as you can see, I already got stacked picture, which you can see here is in linear mode. So I will also remind you that now, if you want to see without stretching what the picture look like, just to see what you're doing, then you can use auto stretch function here. And as you can see now, you've got preview of the picture, but picture is still linear. Another improvement which was introduced, as always you can see, if you open picture, is always greenish. This is because of the Bayer matrix of the color sensor. This is shot with color camera. There is always 1/4 of the red pixels, not pixels, not say pixels because they are filters. 1/4 of the red pictures, 1/4 of the blue, but 2/4 of green. That's why picture is always green before you calibrate it. So when you've got auto stretch, then software stretches all channels the same. But there is new improvement now. You can use here, click this, which will chain or unchain channels. This is it will look at the values of the channels, and it will see that there is twice as much green signal in green channel, so it will stretch each channel individually. So if you click this, you can see that this green cast disappeared. It would disappear anyway after calibration, but now you can see immediately. It's what is called unlinked stretched in other software. Here it's called chain unchain stretch. So you can use that if you want to see picture immediately. It is still linear, but you can see how it may look like already. You can see it has large gradient. Also, what was improved before, what I will show you, this RGB layer will only preview for picture. If you wanted to show something, do any operations, you needed to select your data or points or whatever on those channels. Now it's no longer the case. You can work in RGB channel. It's no longer for preview. It's work as any other channels. So you can see now those channels has almost the same value. Look at green. If I will unstretch this, you can see. So now it's stretching all the same. So that's why it's greenish tinge, because there is so much more. It's double the signal of green channel. But if you click that, he will stretch each channel individually and try to match them. That's why you've got more realistic picture straight away if you click that. Okay, so as before, this was just a reminder and also short description on the smaller improvements like this unlinked stretch, and that you can now work here in RGB mode. As before, now we will go to processing steps. So if you remember from previous demonstration, what I was recommending first of all, you can see there is gradient here across you can see that side of the frame, it's really dark, and that it's much lighter, so it's clearly it's gradient across, light gradient across the frame. I can't remember why it is, maybe there was some moon, or I can't remember. I shot this quite some time ago. Most likely because it's uniform, most likely there was moon on that side somewhere. So that's why I got this gradient. So fifth step I always recommended was to remove this gradient, so you will see better, you will have better signal to noise ratio and better contrast of your picture. So as before, we would go to background extraction, and this is now, before it was just one option, but now you've got two options. That was only, before it was just one, it was this one, polynomial, but it wasn't showing it because it was only one option, so it didn't name it. But now you can use, by default, when you by default this will be RBF, this new interpolation method, which, as I mentioned before, it's slightly better because doesn't require that much sample points. So as you can see, before, it's still, you can use generate grid as before, but you know, if you generate grid, then you need to check if any sampling point of the grid isn't on bright star, or if it's not on nebulosity. You can see he tries to detect where the nebulosity is, but you know, you can see that here, this, you can remove those sample points from nebulosity using clicking with right mouse button, and if you want to add, just click left mouse button. So anyway, like here it's quite a lot of nebulosity. You can see it's red, it's stretching up to here. You can see some reflection nebulas here. You can see a lot of dust. So basically, using this, it's not a good idea, because you know, if you will show those this stuff, then this will get removed, or part of it, together with gradient, because you know, software will think that this is part of the gradient. So if it's picture when you've got a lot of nebulosity, and the best is just clear selection, use this RBF method and just click points when you for sure know. Probably if you pick about 20 points across the picture, showing just, you know, where, showing software the background is. Again, if you want to zoom in, just hold Control key and use your wheel mouse if you want to make sure that you can see there is a lot of dust here. I don't know if you can see because of the quality, but this is dust, excuse me, and I see I can place sample here, so this is better method, and you should place them across the picture, and you can see how much nebulosity is around here. And I was quite surprised, because this is only 2 hours exposure, how much nebulosity my telescope captured. This is 2 hours with f4.5 telescope, so you need to remember, if you've got darker scope like f5.6, to have the same amount of data you would need to expose for 4 hours. But if you've got f2.8 telescope, then you can acquire this data just in 1 hour. So yeah, that's why Astro telescopes with fast optics are expensive, but they will save your time. Okay, so you can see this is just example to show you. I will show you just to show you that you can use just, you know, a lot less points, and just click compute background. Oops. And you can see straight away, you know, I'll go backwards. Okay, I can't because I got this open. Anyway, you can see now that this gradient is, most of it is gone, and now you can more clearly see all those nebulosity and stuff. And you can see, you can then improve further, add additional points somewhere, and then click again compute background and stuff, and you can see there is further improvement. So, but I will show you even better method how to do that using another software which uses AI to do job for you. So, but anyway, if you don't want to use AI, then, you know, in pictures where there is a lot of nebulosity, it's now much better because you can use this RBF, just show much less points. You can see it did quite good job. Anyway, you can add always more after picture is clearer and then improve even further, compute background, and then say apply. And now it should work backwards. So you can see this is with gradient and this is after gradient removal. You can see contrast, especially here, improved, and now you can see even more details in those in this dark dust and stuff. Okay, so we'll go back. So there is another free software which is completely free, and I heard rumors that this part of this software may be in the future incorporated into Siril, the same as Starnet was, and software is called GraXpert. So, okay, again, if you want this software, just go to Google and just type GraXpert, and then at the very top will be web page for GraXpert. And because this is German, you will have, you know, auto translate will propose you German or English. So for us will be English, and then it's completely free. Just pick your operating system, click, and then download it. See, you start to downloading, and this will download not at the beginning were used in previous editions. It was similar to Starnet. It was just zipped file, but now this was recently, like a few weeks ago, it was much improved, and now what is downloading is just downloading installation file. So after it's downloaded, you can see it should download quite fast because it isn't that small, that large. So okay, just a few seconds more, and after you will click it on it. You need to go more info because this is, you know, Windows doesn't know this publisher because it's, you know, niche audience for that. My Norton's is safe. Anyway, just go for more info and run anyway. And when I click it, it will try to install it again. Just click for default options. Just click, you know, it will propose you as all other software. It will propose you where to install and stuff. Just click OK, and it will be installed. And then you should have on desktop icon with GraXpert. So the latest version is 2.1. So it's really simple. Really simple software, and it's free, and it's really good. So basically, if you will see, it looks very similar to this menu. Looks quite similar to what is in Siril already. So you've got here methods of the RBF, which we just I show you this method just in Siril, just you know what it may be. I don't know now, but you know, when I got the first version of this was by default on RBF. So what you just need to do, I don't know, maybe now on the new version default is AI, but if it's not, just go here, click AI, and that's it. And then you can ignore all those grid, because you know, if you make RBF or other, then you will need the same stuff what you did in Siril with those sample points. But if you pick AI, you just need to do nothing. So if you got this AI, you using those three green bars. So first step, it's load image. So this is my image. And you can see, and you know, if this is still linear image, so you should do this on linear image. So if I will go no stretch, then you know it will be not stretch. So this is only for preview. If you want to see gradient better, then you can make overstretch. You will see if I will go 20% stretch, it will be over brightened, but you will see gradient better and stuff. So you can also use this gradient, on process picture, which is already stretched, because if you remove gradient, always if you're stretching pictures, if there is any residual gradient, it will get amplified. So what I basically do, I will do background extraction at the very beginning, just now and just after stacking, like I'm showing you here. But after I finish processing, I very often go back and just check if I don't have any, secondary gradient from processing. And if it is, you can remove it. But if it's, already stretched picture, then you will need to just select no stretch, because it will be already stretched. And if you will have this option, then it will be too bright and you will see nothing. Anyway, so this is this option here, just to show how much stretch you want if picture is still linear. So load picture, if it's unstretched, pick how much you want to stretch. You see if it's too dark, you can go 20% stretch. And now I can see better, you can see now gradient is very obvious. And then just pick AI and just click calculate background and wait a second. You can see extracting background. And you can see this is after background extraction. You can see that it's much better job than what I was doing in Siril. This is much more contrast. That means that background was better extracted. So you can see, at the very top you can see what the original picture is, what the process picture is, and what software extracted. You can see this was a background. You can see it was really dark here, and this is when the moon was. And some discolorations or whatever also will be removed. So also there is
Maciej,
use it as default.
I've got a question here for you.
Okay.
Do you want to pause for a minute?
Yes.
David, do you want to unmute and you can ask your question?
Yeah, so Maciej, you have to excuse my ignorance about the software. When you talked about GraXpert, is that an application where you've got diffuse patches of light, so you use it for processing images like nebulae or the clusters and things like that? Is that what that's for?
Yes, this is for any deep sky objects, basically. When you've got any gradient, this is specifically designed only for background removal, and it can remove very complicated, gradients. I've got really bad picture when I've got some internal reflections when I was shooting with telephoto lens, which is not designed for that kind of stuff. And I had a lot of internal reflections, so I had uniform gradient across, and then I've got some strange like circles, and no other software could remove that, but this GraXpert removed. Also, it's so good. I can show you maybe. Because this was shot with flat frames, so it was corrected. But I can show you what we were shooting with CAG telescopes with John and some time ago and Gordon, and we didn't get any flat frames. So maybe what I will try to do, I will try to open. So basically, if you've got you don't have flat frames and you will have vignetting, this AI is trained so good that it will recognize vignetting. You also will remove vignetting. It's still best, shoot flat frames, because if you've got any specks of dust and stuff, so it will remove this as well, because this is not trained to remove dust. But if I can, maybe I should find it quite fast, so I will show you. I can't remember where it was. It's here, CAG, and then we've got Astro run, say M45, and this is stacked picture. So you can see it's much brighter at the center, and you can see clear vignetting, really bad vignetting, and you can see it's also optics are not centered very much because vignetting Sorry, it's much bigger here, smaller here, but again, just click calculate background and you will see it will do a really good job with removing. You can see it's now uniform. And if you will go to background, you can see this is basically a flat frame.
Okay.
So you can see all this vignetting and stuff. So yeah, it's really good. As I said, it can remove, this AI can remove very complicated gradients. Maybe I'm not sure if I will be able to find, if I will be quickly able to find, and I will show you this picture with those bad gradients. I think it may be this one. So yeah, you can see there was bad gradient because it was a moon. You can see gradient across, it's really bad because it was moon. And then you can see there is some circle. This is, this was also with flat frames, but that flat frames didn't do really job. So I think that was some internal reflections in because this was just zoom lens, cheap zoom lens, so not telescope. So, but again, if you get calculate background, you see it will make it flat. And if you will go to see background, then you can see how complicated it was. Dark, brighter, dark again. So typically no software can do that, but AI, it will recognize that, and it's really good. Removing, as I said, even if you've got some internal reflections, most of the time it will get rid of it. So you can see, oops. So you can see that's background, that's original, really bad, and process much flatter. You can see much more. It was, this is a lot of noise because that was just a short exposure, but you can see it looks much better. You can still see here. So if there is a smoothing factor here, normally when by default it will be here at 0. That means that it will remove background gradients very aggressively. It will make, so if I will go to 0, maybe it will improve a bit this one. But by default is, as I said, the 0, but I do not try not to use it 0, especially if I know there is a gradient, just from moon across which is, just uniform gradient. Because sometimes if you make this smoothing, I recognize that sometimes it will remove a bit of nebulosity. If you will go to 0, you will not see, you will see in the background that it removed some color, not here, but in those pictures which I'm using for demonstration. When I went to background, you can see it was a bit of red where the nebulosity is, so it extracted a bit. But if you will go to picture, you cannot see difference. And even if you will go smoothing to 1, 0 to 1, 1 is very... Sometimes if you see there is a lot of nebulosity removed, and if you've got not very strange gradient, just, normal gradient from the moon or whatever, it's better to go closer to, closer to 1. Okay, so I will go to today's talk. This is my picture, which I'm using. Okay, so as I said, to answer your question, yeah, this is only dedicated to gradient removal, and this is AI just trained for that, and it's free. And if, those speculation I heard are true, then it may be incorporated this also in Siril in the next, couple of months, similarly to how Starnet was added. So you can see this is already very similar to what in Siril. So basically they just need in Siril add this AI option when you can just click AI. But for now you need to use GraXpert, but it's free, so, and it's 5 minutes to download and install, so why we should not use it and have the best result, even if you got really bad gradients or you didn't get flat frames or whatever. Okie doke, so like here again, load image, as I show you, I again calculate background, and you will see if I will go to background. This is what was extracted. You can see a reddish tinge here. So it looks like it's extracting a bit of nebulosity. So if you see this, this is what will be default. If you don't, you can leave it, because you know this loss of color is not much. If you will go here, the process, you can see, you can still clearly see it's extending it or over. So, but you know, if you assess that it's maybe some excessive, just try. And gradient here, it's very uniform. You know, there is not rapid, you know, changes like it was in this picture before, which I show you of from telephoto lens, when gradient was changing very fast. It was, you know, some circle in the middle. So for stuff like that, it's better to go here with smoothing, you know, default smoothing. But if it's here uniform and you see that you are losing nebulosity, maybe go try 0.07. So if I see that I'm losing nebulosity, I will try something, you know, like 0.8 and do this again, and then look at the background and see if, you know, if it's less color, if it's the same amount, which I think will be here. Yeah, you can see still it's the same amount. So most of the time I will go back to, I'm using most of the time 0.1, but you can keep it on default, because you know this is how aggressive it will be removing gradients. So if I would have, say, 0.8 and had this bad gradient with this lens, then you know it would be not that good, because it will then spreading this transition over larger area if you've got this smoothing high. But if you've got 0, then you know this will be more compressed, so it will be more variation to the gradient, will be, you know, then basically this is removing gradient more aggressively. So you can keep it by default. When you install it, this will be on 0. I most of the time use 0.1, and you know sometimes I will try a few values to see background if it's extracting less nebulosity or not. But most of the time I'm going back to 0.1 anyway. So basically those are, this is quite simple. After you picked AI, you've got just using those 3 buttons: load image, calculate background, and then save processed. And then it will propose you to save it to the same location when the source file was, original file, and it will propose you the same name, and will just add GraXpert. And then you can pick here if you want TIFF or whatever. By default will be fits, because fits are, you know, for astrophoto files, but you can pick other if you want TIFF or whatever. Especially if you have, you know, stretch picture, it may be in TIFF, so you can maybe save it in TIFF as well later. Anyway, but you know, you can pick whatever it is. For now, we've got still linear pictures, which was in fit file, 32-bit fit file, so we will save it the same format. Just click save processed and just click save, and you can see saying calculating. Now it's done, and now it's, and so we go back to Siril. Okie doke, so now we are back in Siril. So now we removed gradient, so now we need to load this. This is with gradient removed. So this is our picture. So first step basically was always gradient removal. So after you've got stacked file, then instead of going to Siril, go to GraXpert, extract your background with GraXpert, and then just load it to Siril. And don't use this background extraction here. But if you for some reason don't want or whatever, then I show you how it was improved here anyway. How it requires, new algorithm requires much less points, and it's much easier. But you can see, I don't know if you remember my iteration from Siril, but you can see that GraXpert did much better job. You can see it's much more especially this dark nebulosity visible. That means that did better job because it's better contrast. Okie doke. So first step would be, as always, removal of the gradient, and but we can use GraXpert if you want, which is also free, and I show you where to find it and how to install it and how to use it. Okay, so after we've got that, so picture is for sure still linear. So what I will do, maybe, because you know I can see that I can feel that my voice is fading simply, so I will maybe show you. Okay, I will maybe show you now this deconvolution, because this may be I was thinking to include it as a bonus, but maybe because the convolution, as I mentioned, it should be used on always on picture when it's still linear, because you know all data is linear normally when camera gathers it, and the algorithms are designed to deal with linear data. So you should always, this looks like stretch because we've got just preview auto stretch, but delta is still linear. So okay, so to use this deconvolution to get any, you don't need to use it, but you know I think it improves sharpness and you know signal, you can see more details, so I think it's worth to use it. This is just to minimize the blur of the atmospherics, and as I said, even slightly mishaps with guiding and stuff. So the easiest way is to to do, just if you don't know, or if you don't bother, just click blind deconvolution and apply. But this is, you know, quite this is quite a lengthy process. It requires a lot of computing power, so after we look at your picture, we try to guess what the convolution should be. So if you will, if I would do apply, I would need to wait probably 3 minutes, and then you will see slight improvement. But you know it's better to, you can do better job yourself, and I will show you the simplest method how to do this. So the best is to use, you can see it's blind deconvolution. The best is use stars. Tell the software to use stars to assess what the atmospheric blurring was, because as I mentioned before, stars are just theoretically should be points of light. So the best is just make PSF from stars. PSF is short for point spread function. This is, you know, what this software is using, because you know it's this function takes into account not only atmospherics but also how light is distorted by lens, you know, when it's passing through glass in lens and stuff. So it will try to assess from that. So software know that should be point, but because it's bloated, so it will try to guess what atmospheric was distortion due to glass and stuff. So to use this, we need to go close this for now, go to image processing, and now after integration of Starnet to Siril, they created whole menu called star processing that was not present before, and this includes not only Starnet but also the saturate stars function and full resynthesis of the stars. So this is not correlated with Starnet, but because there was Starnet and this is all operation on stars, they put it all together to one menu, which is star processing. So you can see you've got COGS here. If you click on that, you can see this is dynamic PSF. So what you need to do, normally if you want to get stars, just click stars, you can see, and now I will need to wait. And then he found all the stars, not all stars, you know, but they are thresholds. You can, you know, if you want more stars to be selected, you can see the fainter are not selected. If I will, you know, lower the thresholds, then I can get more and more stars till I get all stars. But if you go too low, also it will start to recognize noise as a stars. So by default, those are just use those normally if you want to select stars. And after each selection, you can see some stars are orange and some stars are purple rings around them. So those stars which has purple rings, that means that they are saturated, so there is no color in them, or most of them. So this is when you can use this function, the saturate stars. So it will just dim those are the brightest stars. If I will click it, you can see here it's processing now, and it finished processing. Now they are still showed that, you know, they are, because I need to refresh it, so I need to deselect stars, which you using this, deselect stars, and then select stars again. And most of the time, almost all will be gone. Sometimes will be 1, 2, or 3 stars which didn't desaturate properly. You can see I got only 1. But now, you know, we've got desaturated stars, which is nice because, you know, we may be able to recover color from them. So this is another function which was introduced together with incorporation of, you know, Starnet, but this is not part of the Starnet. But this is also a new function in Siril, which was not before. But we are interested in PSF for deconvolution. So for that, the best is use not all stars, but average stars, because you can see some stars are small and some maybe not stars at all, but maybe noise. So you can, the easiest is to limit using amplitude range. Most of the time, you can see 0 to 1, so you will include all stars which are in this threshold anyway. But, you know, if you want just average stars, I always use for that from 0.1 to 0.7. And then click stars again, and you will see now you will have much less stars. I can now close that. So you can see it only pick much less, but, you know, more average stars. So they are not too dim, not too bright. And then now we can use this in convolution to tell software, the convolution software, that it should use those stars to create PSF, this point spread function using those stars. So we've got those stars selected, we click PSF from start, and now generate PSF. And you can see here PSF was generated from 731 stars. Most of the time you don't need to do anything here. You can see this is preview, and this is how many pixel by how many pixel preview is. Most of the time, if you use that, then average stars will fit here and you don't need nothing. But if you can see that star is too large or very small, then you can change that. But most of the time it should work how it is. Also, now we've got this we've generated PSF now, so now we need to pick the convolution algorithm. You can see there is 3 deconvolution algorithms. But if you will go and hover over this, you can see comments. Now there is also improvement in Siril. There is a lot of comments everywhere if you don't know what is what. So you can see once the PSF is estimated, which we did, or provided the image is finally the con blah blah blah, then you need to select this algorithm, and then it will tell you choose Richardson-Lucy for deep space image, or choose either split Bergman or Wiener filtering for lunar or planetary. So we know we've got deep skies imaged, so we need to use Richard-Lucy method of the convolution, which is selected by default anyway. But, you know, as I said, if you are not sure, just hover, it will tell you what is what. So this is by default. Leave everything how it is here. If you've got very noisy picture, then you can limit this, because, you know, this will sharpen the picture. But if you've got really a lot of noise, it will also sharpen noise. So this will go with iterations, so you can limit those iterations here by clicking this button. But, you know, if you've got quite decent data, which you should have, because otherwise it's no point, you know, processing. But then, you know, you can clip this, or if you've got some other data. But by default, for first run, just leave everything how it is and click apply. And first time, this might take, you know, I've got quite fast computer. which has 6 coprocessor and runs 12 threads, but still at the beginning you can see no FFT wisdom found to import. It will create some like a database of this picture. So first time will take quite long, about 2-3 minutes in my case, but if you've got laptop or smaller computer, it may take 10-15 minutes in your case. But this is only once, and then we will see, we need still checking. You can see starting non-blind deconvolution, you can see what it's doing now. And also my computer may be working a bit slower than usual because I've got recording running in the background. Anyway, I will start explaining you what will happen most likely. So after this will finish, you will see that those stars here will get tighter, smaller and sharper, and you will also see that, you know, edges around nebulas like here is very good place to check because it's good contrast anyway. You will see this will get even sharper and more detailed. And basically I will start with this value. But you know, if you see that improvement, you can see improvement, and you don't see rings around the stars, then that means that it's maybe further space for improvement. So then you can add 1, just click plus and you go 0.4, and then click apply again. And second time it should be much faster because it will have this wisdom, whatever it's called, and you can see now start Richardson deconvolution. So it's now actually doing, should finish shortly. Or you can see now it finished. So if I will go back, just look at the stars and those Horsehead Nebula. You can see they are got tighter if I go forward and backward. But you all can, yeah, I don't know if you see, you can see now, you can see there is even here on the head, it was just like blur detail. Now the blur, this is like concave on the top of the head. I can see it, I don't know if you can. But yeah, for sure it's improved picture sharpness, and also all the stars got tighter. So, and there is no ring, so maybe if you could go one more and then click apply, and then you will see now it's starting non-blind deconvolution, but it's going, you know, because it has this wisdom imported. So I don't know what it is. I think it's some kind of database of the picture. So you can see now I went to 4, and now you can clearly see, at least I can see, there are rings around the stars. So it means that we overdone it. So I will go back to 0.3 and apply again. So it's applying the convolution. But that's because I didn't go back and I applied the convolution at top of the convolution. Okay, so I should go back and then apply the convolution again. That's why the rings didn't disappear. They, again, if you doing something, you don't need to generate again. If you didn't close picture, you don't need to generate PSF from stars again, because you can just click previous PSF. You don't need generate. You can go back straight back to the convolution. So I just go apply. Yeah. So don't forget to click back after you are not happy with with your previous result, because I forgot and it just put the convolution on top of the convolution. So I can see rings still for some reason now. Maybe he lost his wisdom or something. Anyway, just if you can see ring, go lower, go back, go lower, click apply. So that's how you should work with that. Basically, the only parameter you should mess with is this one here. If you don't know what you're doing, something went wrong, because, you know, I've got still rings before. I didn't have them before. Maybe because I should, you know, maybe because I should regenerate my PSF. I don't know what the problem is. But anyway, this is just to show you how it works. I will not bother with that too much. but this is quite useful. As you've seen in previous iteration, it was clear improvement, and you should try to go with this parameter higher or lower, depend on the stars and if the rings start to appear. As long as there is no rings, you didn't overdo this. So. But again, if you don't want to deal with it at all, just click blind deconvolution, and you also will be better result, but not as good as I show you using PSF from stars. If you will click blind deconvolution, it will take even longer to generate, you know, all this stuff, and effect will be not as good. So you should always use PSF from stars. I'll show you how to select start using image processing, star processing, and this stuff. Just use 01 to 07 amplitude range and stuff. After it's done, if you want to select stars, you always go back here and click that. Another useful function of that, which is here, I will show you as well. I will just go with picture 2. Is this function, which is estimate sensor tilt. So if you click this, software will look on the stars and how are there, if there is any distortion in the stars, and you can see it will estimate if there is any tilt of the sensor. That doesn't mean that this is tilt on the sensor. It may be tilt on the sensor if you've got, you know, some too flexible connection between camera and your telescope, but also if you've got Newtonian and it's not very good collimated, or, you know, camera is not exactly in the optical axis and stuff, all this will show here, and then you can use it to correct your, you know, light train in your telescope or collimate your Newtonian or whatever. But this is very useful also for free. So this is where you use it. Okie doke. So deselect everything. So this is another new and useful, but do this, you know, you should do this when you need to do this, when picture is still linear. The convolution. Also, I noted there is also, which I didn't mention before, there is what is called banding reduction. Is you use, this is especially bad in some Canon camera, and I noticed it's especially bad in my camera, in my modified camera, because this was cheap camera. It's not a problem in my Canon 6D or 7D, but if I click that, you will see, you cannot see any banding because you cannot see them. In some pictures it's very obvious I've got banding, especially at the bottom. Here it's not so obvious because most, you know, part of it most likely GraXpert removed. But you will see if I will go that, just leave by default how it is one, click this protect from highlights and click apply, and you will see it will get even flatter. I don't know if you see it. I will go backward and forward. If you can see, there was some banding which wasn't that obvious, but after you use it you can see now that it was. But this is only for DSLR cameras, useful for DSLR cameras, and most likely if you've got cheap Canon, but you can always use it. See, if there is no banding, there will be no change. So, but you know, because if you do not remove that, this banding will it will be quite obvious after you stretch your picture. So it's the best remove it now after you did it. Sometimes you can also try vertical banding, but I know that this sensor doesn't produce vertical banding, so I didn't do this. So I just close it. So that was before, but you know, I didn't use it because I didn't know that I've got a problem, but I know now that I've got. So if you're using DSLR for your pictures, you can try this banding reduction. Just keep the default, just tick protect from highlights and run it, and that's it. So okay, so we did that. So for sure we should also do as before color calibration, and as before we've got photometric on color calibration. I showed you before how I do that, so maybe I will quickly show you, although I never remember what Horseheart Nebula is number, what is, so I'll go quickly just trying to find, yeah, I think that should work. That, you can see here. Then again, you need to, if you were shooting with, with Astro camera, then this data about the focal length should be already, included in your feeds file. But because I was shooting with the SLR and I'm using not feeds file, but I was using original files from camera, that's why there is no information. But I know that my focal length of my telescope is around 275 and pixel size is more or less this. And then just click OK and hope that it will plate solve that. So now it's plate solving. Or something hung up. Can you still hear me? I'm not sure if only Siril hung up or everything hung up. If anybody can let me know if you can hear me. Can you hear me?
Yeah, I can hear you.
Okay, so that was just problem with Siril. I wasn't sure if that was more general problem with my. Okay, so I'll restart Siril. Okay, so we go. Okay, so that's most likely just Siril hung up. It never did this before, but maybe because I was doing too much stuff at once. That's maybe what he did. Okay, so we'll go back very quickly. I will go as a reminder what I did, because it didn't, so I remove gradient. I'm back in Siril. Now what I'm doing, yeah, okay, so I will skip the convolution and stuff. We will go just straight away. And also what I didn't mention, just remove green noise as well. Just go whatever its default, close. Remove green noise, banding reduction is very useful in my case, so I will apply that. Close, and then as before you will then next do color calibration, but as I demonstrated maybe before, and yeah, it lost. Okay, paste, find. I'm not sure, hope that it will not hang up again. If it hang up, then I will skip doing that. Okay, I think it worked now. I'm sure. I will go to console. Yeah, photo. So no, I'm not sure it hung up before. So we've got color calibration. You can see before and after. So it's now much more neutral. It was red tint all over the picture. Now it's, you can see it's calibrated. Okay, so the convolution I already showed you. So next will be, we've got calibrated more or less everything, so that's the best now to remove stars. So we've got this still linear, we can see only because we are in auto stretch viewing function, but in fact picture is still linear. So now we will extract stars. It's, as you can see, there is a lot of stars in this area, and some of them are really bright, and those are Orion belt stars. Alnitak is really bright, so even if we remove those stars, this halo will remain because software will think this is nebulosity. But anyway, this is a lot of stars here, so before we will start stretching picture, in pictures, especially picture like this, when it's close to Milky Way or when there is a lot of bright stars, or basically a lot of stars, it's the best now to split pictures by removing stars. So here we will go just image processing, star processing, and Starnet removal. And now you've got, this is by default will be always like that. So because we've got a linear picture, we need to tick this, press stretch linear image. This is because, you know, Starnet normally requires stretch picture to see the best stars. So what this will do, because this is completely linear, this will stretch picture but just slightly, just to show to Starnet what the stars are. So it will just, because it's linear, we need to click that. If by, you know, if you forgot by any, this is the best now moment to separate stars. But if, you know, if you forgot to remove stars, or stars, you know, you thought that they will not be harmed because they were small or whatever, and you stretched picture, then you can still remove stars with already stretched picture, but in that case you will not check that box because your picture will be already stretched. But ours is linear, so we need to click that. And also we need our stars because we will recombine them later. So this is always ticked by default. And, you know, I like stars, so I will always add them later. But, you know, I've seen some pictures don't like stars at all if if they've got a lot of nebulosity. So if you are one of those people and you don't need stars, you can untick that, and then it will not save your stars. But I like my stars, so I will leave it how it is and just click that because it's linear, and click execute. Now you can see it's doing all the work which you normally would do manually. It does in the background. It will convert the file to, first it will pre-stretch it, then it will convert it to TIFF file, send it to Starnet. Starnet, now you can see running Starnet. Starnet is now extracting stars, which is the most resources consuming process. So for that, again, you need to have you don't have to have very fast computer, but it helps if you've got, because if you've got laptop or old computer, it might take a few minutes to, especially if you've got high resolution picture. This is 24 megapixel picture, so it's quite a lot of resolution, but, you know, here should take probably half a minute up to a minute, and you can see it's over half already done. But again, if you've got older computer or using laptop, then that's probably the point where you will go and make you some cup of coffee or whatever. Normally it's going here much faster, but as I said, because I'm recording in background, that's probably slowing my computer down, but it's nearly finished anyway. So after it will finish, what it will do, it will generate two files. One will be with background and including all the nebulosity, and other picture will be with stars. And as I said, you can see now there are no stars, there are only halos remained from the brightest stars, and you can see some weird artifacts from here, very bright. Alnitak is not bad, but this was close to the field of view. It had some distortion, and that's why it causes artifact. This, you know, after recombining stars, this will disappear because this bright star will appear here again. But you can see now how much nebulosity you can see. So what he's doing, we had our file which was called result and GraXpert. You can see what he will do. It will get our file which we started with, and it will create two files. So it will never, if something went wrong with splitting stars, you will still have your original file. If I will go to my directory which I'm using, and which you should have here, because as I said, you need to show Siril where your directory is. He will be outputting all file here. So this was our first file, stacked file. This was our GraXpert, so background removed file, and also with processing. What was wise to do was save before I split the stars, but most of the time, I would save that as GraXpert calibrated. I didn't do that now because that's probably because I'm ill and not on my best. But you will see that you will have always original file, and you've got two new files. One is called Starless, which will be opened by default by Siril, and then you've got also Star Mask, where your stars are. So if you want to see, those are already saved. So if you want to see how your stars look like, just click open, and then you've got all your files. So Star Mask, if I will open Star Mask, it is all bloated because I've got auto stretch, and auto stretch doesn't work very good on stars alone. So, but if you will go to assign stretch, you can see we've got all our stars here, which we can stretch independently from nebula. Okay, but first of all, we will stretch nebula. So we will go to Starless result, and then we've got our mode. You can see it looks already quite good. You can see a lot of dust. You can see also it's quite noisy because it's just, as I said, it's just 2 hours. I was planning to collect more, but because weather was so bad for so long, I decided to process this picture, which at the end wasn't that bad because I've got another AI for removing noise, which will not cover here because first of all it's expensive but anyway, so we can see it's a lot of star, and now it's time to move to stretching and show you how this new method of stretching works. So to go stretching, you can see that it was pre-stretched, but you can see the stretch was minimal. If I will go to linear mode, you can see basically nothing, like it's not stretched at all. So the pre-stretching for star removal is really very small. Okay, so now we've got this picture which will be start to stretch, and then I will show you how to use this another big tool, which was a very large improvement, which is called Generalized Hyperbolic Stretch Transformations. So if you open that, you will have your histogram. You can see all data. It's as always in stretch picture, because it's not stretch, all data is pile up to the left, which all the darks are. And then you've got some options and some sliders. So this is main function of this generalized hyperbolic transformation, which what it is. There is also inverse. That means that you've overstretched, you can try to destretch using this. Then is this modified R-sine hyperbolic transform, which I also described you before. It is also as still it is. Before I was using this as in transformation, so I already showed you in previous. So you can still use it here, but it's also now included here. If you want to change, just go here and say modified R-sine transform. And to remind you, this is if you want to preserve a lot of colors in your picture, then you can use this for first two or basically 2 stretches. It's recommended not to make with this more than 2 stretches. But I will not use this here. I will use it here because we can improve our color. Always color get hurt when we stretching. You've got now here what algorithm you will use, and this must another algorithm for how color will be stretched. So by default is independent channel values, which is normal stretch. If you use curves or levels in Photoshop or any other software, this is what it will use for color stretching. That's why more you stretch, less color will more and more disappear. That's normal. If you make something brighter, it looks like it's has less color. That's why if you've got landscape picture and you will decrease brightness, more colors will pop up. So this is always related to brightness of the picture. So when we're stretching, color will be less and less color in the picture. So, but there is another models here, like human weight luminance or even weight luminance. So what I will recommend using for first free for stretch, I will recommend to stretch even to this one or this one. You can change later after you stretch, and we will see something. You can pick which is better. For me, it may work differently for different pictures. Most of the time I will use human weight and luminance. So what it will do now, it will stretch brightness, but it will know that, more the brightness you stretch, so when you're stretching, you basically increasing its brightness, then it will know that it should preserve color. I don't know how it do this, if it's at saturations or just other algorithm, I don't know, but if you will pick that, it will preserve more color when you're stretching. Okay, so now this is what this is for. Now we've got stretch parameters. So this is basically, if I will not mess with any of that, if I will start drag this, you can see this is stretch curve. So this is, if I will not use any of that and use only that, then this is like normal stretch. So it just increases brightness, and you can see here that it's just shifting your data curve to the right. That means that brightens everything, but you can also see everything what touched the ceiling. That means it's clipped. So all those whites, they are now clipped. So to avoid that, we've got all those other sliders. And also you can see now, because I've got pre-stretch, with that, this is still not applied. So I can now show you how color, you can see how color faded if I went to standard color stretching. But look now, especially on the red and on those two colors and yellow, if I will go to human weighted luminance, you can see how much more color it is. I will try also this one, maybe it will be better. It's probably the same, so I will go back to human weight luminance because I'm human, I think. Okay, so this is what this do. This fifth slider is basically your curve when you add how much stretch you want, how much, how this transform curve will look like. So yeah, so this normal stretch. Then you've got local stretch intensity, and then is symmetry point, and those two are connected together. Basically, what is local stretch intensity is if you want to improve contrast, if you ever stretched your picture in Photoshop, so you will have at the beginning, you will make your stretching with curves similar to that. You will just drag on the top and go up to brighten image, but at the beginning, at the later stretches, what you will do is S-curve to improve your contrast in your picture and reveal more data. So this is what this does, and this work together. Symmetry point is where this S-curve will have, point when it changes directions, and this intensity will be how much contrast you're adding. So to show you more or less how it works, what maybe I will do, I will go here, just look at this curve here, and now I will click, say, to symmetry point. You can click somewhere on the histogram where you want it to be. I will click here, or maybe not here, even here, and you can see now that this changed direction here and here, so I will stretch even more, or maybe not more, or maybe I will move even further this, just say I will go 1, probably too far, okay, say 0.6, oh, you can see now clearly, so you can see now it's like S-curve. So this is symmetry point, it's here. And then you can see local stretch intensity. Look, what I start to drag, you can see what it does. It just makes this S-curve much sharper, you know, much more prominent. That means that it will be adding more contrast. So this is how it works. That's why if you leave those in default positions, those two, which is here should be 0, and here should be also 0. Then we've got normal curve. But if we use those 2 points, then we can use contrast to reveal more data, and we can decide in which part of the picture we want this contrast to improve. And this is what makes this really powerful, because we can apply those S-curves very precisely in very, you know, narrow band, not narrow band, but narrow band of data. So I will show you how the best, you know, this is a lot of theoretical stuff, but I will show you now practical stuff. If you don't know what this does, what you should do if you don't care, you know, remember all this stuff. So what we will do, we will just reset all what we did, and then first stretch. So we will go, just to remind you, generalized hyperbolic stretch, and for few initial stretches I would recommend you to preserve more color, switch color stretch model from standard, which is independent, to human weight luminance, or the other one below. So, and now first stretch, you don't know where the data is, right? So what we can do, we've got histogram here. As you can see, it's all very dark, or to the left, excuse me. So what you can do, just you can use either that, click, or you can just type from 1 to 100, say I will go 80, to zoom in to the histogram to see it much clearer. If you are zooming, it will always zoom. If you use this, it always zooms to the left hand of the histogram. If histogram disappeared here, you can use this and find it where it is. So this is, you know, when we start with, we've got everything by default 0, and we cannot see any data yet. So how you establish where the symmetry point should be? So there is 2 ways to show that. You can even type here. You can show on the histogram, and third method, which we just use in a second, is to pick from the picture, but we cannot pick now because we cannot see anything yet. So for first stretch, what is recommended by authors of this whole stuff, which guys who invented this, is just go to your histogram, and you can see it's going up and then going down. And on this first select, when it's going up, go to the half. You can see this is in the half, there is slightly thicker line. Just click here when it intersects, first select going up intersects with this middle line. Click it and you can see it's really small value. And this is your first symmetry point. And then with local stretch intensity, you need to go all the way up. And then you need to start stretching picture. Now we can get out from that. The simplest is just type 1. And then now start stretching. Use this and look on your screen. And you should stop stretching when you start to see more or less main features of your pictures. I don't know if you can see, but I can clearly see, you know, flame is for sure see, but I can also see main feature, a bit fainter feature of Herschel Nebula. I can see head here, and you know, I can start to see this glowing red. So this is first stretch, and you should, if you start to see those main features of your picture, then you can, you know, that's when you should stop with first stretch. You can always go, if you don't know what the main, you never stretch picture, if it's new area of sky you don't know, you can go just overboard just to see better what is there, and then just go back until you now know to expect. So those main brightest feature you should stop first stretch after they will appear. So I would stop my first stretch right here. So this is not applied, so before we can go further we need to apply. That's why we can go, you know, before we apply we can try some options and see what is what. But now, you know, after you click apply, you can still reverse that if you make mistake, just going here, closing that, going back and starting from the beginning. But you know, after you applied, and now we can clearly see some stuff. So initial step, to remind you, just go to histogram, click it for when once you know, as long as nothing is here visible for first stretch, go to histogram, just zoom into the histogram, click to establish your symmetry point, click on first leg, half, then go with local stretch all the way up, and then start stretching using this slider until you see main features. So this is first stretch. Second stretch, and also if you want more color, just keep this human. For second stretch, now we can see something. So your symmetry points should be when you can still see the data, like I can see there is nebulosity here, and just starting to fade into your background. So what you should do, just you can now show where you want, which data you want to stretch. So you should pick those faintest data, this data which is barely visible but clearly visible and it's about to fade to your background. So for me, I would pick that here and just show it, you know, just click and drag and it will draw small rectangle, and this is area which you want to use as reference for your symmetry points. So when you've got marked this, just click this dropper and you can see he automatically found this picture and its brightness, and he now knows that this is a reference point where this symmetry point for improving contrast should be. And then now for local stretch, in those early phases you can still use it quite high, but I would use no more than half for second stretch. So maximum is 15, if you remember. From first stretch we use 15 maximum. For second I will go about half of that, 7, whatever. Just say at the beginning this much, and then start stretching. And now you will need to move less and less of this stretch to show more and more data. So again, you should use small steps for stretching. So I can see now, after I stretch a bit, that now it's more faint stuff appeared here. You can see before it was here, was rarely visible, and that was completely black. Now I started to stretch what I barely see, and now I can see more. So again, if you want to see what this, how, because now stretching will be balanced of those two, this also can act as stretching. You can see if I increase that, brightness increased and stuff. So you can see what works better for, you know, for your picture. But basically for second stretch I will go with local intensity about half. Most of the time I'll use about 7. And then increase contrast till I see more faint stuff, like now. As you remember, I seen barely just this. Now I'm just stretching slowly and see if I can see more data. So I will stretch a bit more. And now I can clearly see it's some data here appear, some data here appear. So I will apply that and repeat that again. So now I want, this is, you know, feature, it's very faint and is about to blend into the background. So I will pick that feature. And now I click again symmetry point, dropper, and then in each stretch I tend to use less and less local stretch. So now I will use half again, about 3. And then I will use stretch to brighten the picture. You can see now it's brightened more and more aggressively with every step. So if this will be not very accurate, you can use those values, it will stretch very slowly, more precisely. But most of the time at the beginning you can still use that. So just stretch. I would say that that's enough for me, because now I can start to see some dark nebula, so I will try to put more contrast in here to reveal this. So I will click apply to that, and then you can see now I'm stretching more and more, and you can see my background is brighter and brighter, because you can see all the histogram, it's going up that way. So it's like now I think the background is now too bright. So before further stretching, what I would do, I would move the black point to the beginning of the data. And to do that, what you need to do, just go here, and at the very bottom is what is called linear stretch BP shift, which stands for black point shift. Just click that, and then you can either use this slider, and you can see if I use it, data is moving back that way, and background, whole picture basically, background is getting darker. So it's good to do that, just to zoom in and do this. So you want to go with as close as possible to the edge, but not to clip any data. If you will go overboard, it will keep data. You've got here guide. So if you start to clip data accidentally, say I will go now, you can see still got some room. But if you are on the edge, you are sometimes not able to tell if you are clipping or not, even if you zoom in very far. But you can see here that I started to clip data. I clipped 0.01% of data, so I want to back up. So see, I clicked here, and now I know I'm not clipping any data. And now I will just apply that. And now we've got, you know, our black point established, which we know is correct, and we know we didn't clip any data. We can go back to Generalized Hyperbolic Stretch and keep doing what we were doing. So this is probably last time with this stretch, which I will do now. This is last time when I will use this human weight and luminance, and later on I will start using normal, just, you know, to not overcolor this picture, and not to, because if you will overcolor your picture, sometimes you can lose some data, because saturation will also cover some of the details if you will oversaturate your picture. So most of the time I will use this color stretch method, human weight and luminance, for free, most likely for 4 stretches, and after 4 stretches I will just switch to normal. So we do the same stuff as we did before, now with picture brighter, so it's darker because we shift our black point. I will go back to unzoom this. So, but we can see, I can see at least that there is some dark nebula here, so I will use that as symmetry point. Excuse me. And again, now most of the time I will be using now just about 1 to 1.5 for local stretch, and all stretching will be doing just with that stretch factor. So you can see now, because we shifted black point, we've got even better contrast now, and we did that without clipping any data. So now we reveal more. You can see, you start see a lot of dust now. So I will again apply that to pick even fainter area, but as I said, I will now go to default independent channel values, not to oversaturate this picture, because as I said, it may be some details in those hydrogen clouds. If you oversaturate it, then you will lose those details. So what also picture is starting to get very bright, and we may start to clip some of the stuff here. So I didn't tell you about dust 2 sliders. You can see, but they are self-explanatory. You can see shadow protection point and highlight protection point. This is to make sure that when you're stretching, then you will not oversaturate the brightest part of the picture, which most of the time are stars. So this is even good, much better. Even if you didn't separate stars, you can try to minimize star bloat by using this highlight protection point, but you know, it's always to best saturate star. But we can see that this, you know, those are those halos with very bright alnitak, and this is also small reflection nebula which has hot stars. Stars are not there, but all this they are so bright that they created halo, which software didn't remove because it thought this is nebula. So now to protect this from overexposing, you know, from over bloating, from now on I also will be using this highlight protection point. Most of the time you can start using from the beginning if you are not sure, but you know, I can see from histogram that, you know, I'm nowhere near you know, overexposing this, saturating this. So, but now I can see by eye that this is quite white. So if you are over cautious, you can start this using from the beginning. What I use always now, if it's quite bright, I will always use about 80%, 0.8 more or less. And this is basically highlight protection point. What that means? That it will not stretch the brightest part of the picture, which will protect them from stretching. So the brightest parts of the picture will not get stretched, if that makes sense. So because we are here bright, and I will start using this, but again, method is the same. Now I can see some stuff started to appear here. It's barely visible, some dark, you know, blob of dust. So I will pick that one, or any other similar value, you know, similar brightness dust. But you know, basically the best is pick stuff where details, where you want to reveal details. I would like to see, you know, it will be revealing details because it will be increasing contrast this. So that's why it's the best to pick what you can barely see and which is close to fading into the background. Okay, so I will pick that, but you can also pick, you know, like here or here, something similar brightness. And again, pick that. Now I will be using we are now near the final stages of stretching, so I will be using about one always here, and then just stretch here. And you can see now less and less movement. Okay, so you can see how much more dust we now revealed. You can again apply and check for any more faint stuff appearing, like here. But you know what I can see, I know this is not a lot of exposure, so this picture is slightly starting to show a lot of noise. I'm not sure you can see. So if I had, like, you know, twice of the data, I could go on probably 3, 4, 5 more stretches to reveal more and more of those dark stuff, which is, you know, really interesting. But because, you know, this is not a lot of exposure and I'm starting to reveal a lot of noise, that will be last stretch which I will do. So I will just pick this again, pick this at symmetry point, go about 1, and then just a bit of stretching. Okay, and that's it, because I can see more and more noise. And I will apply that. And no, before I apply that, I need to protect my highlights. So I will go again about 0.8 and then apply. Okay, and that's now, as you can see, we done stretching. It's, you know, it's a lot of, takes quite long with explaining stuff, but you know, but basically this is, you know, quite quick process if you know what you do. And to remind you at the beginning, you just, for first stretch, you need to go, just a reminder, generalized hyperbolic stretch. For first stretch, when there is just black, nothingness, just zoom in, click here for first black point, go local stretch intensity all the way up, and first stretch should be just to barely see main features of your picture. Then for second stretch, just pick the faintest part which you can see, which is about to fade into darkness. Make local stretch about 7, and then start stretching till you will see some fainter start appear, and then just repeat the process as far as you can see, as far as you can, expect to see stuff. As I said, I could probably stretch more if I had better data, because you can see a lot of dust is here. But after you are happy, or you can see that your picture is starting to going apart because it's too noisy, then just that's end of your processing here. So it's just few iterations. It's better to make more smaller stretches than few bigger ones. And at the beginning, remember to pick human weight and luminance for first 4 stretches to preserve color better. Okay, so now we've got our image. Say we are happy with that, how it's stretched. So what I would do, I would save it. So click that to save as. If you want save this picture as for under the same name, then just click save and it will update this picture. But it's a good idea to have your basic picture in case something went wrong, so you can just go one step and start to stretching process. So what I do normally, I will just save that, save as, and I will just add stretched to the name, so I know that this is my stretched background without stars. And again, he will ask you about what you want to save as. I want this as fit and 32 bits, how it is, save. Okay, so now there is, say we are happy with that now. So basically there are 2 options now. We will go normally to stars. So what we can do, we can go to pictures with stars if you want, which is star mask, to remind you. So this is in linear, so you barely can see them. So what you can do, there is 2 options. You can start stretching those stars here, which is this picture, before recombining them with your background. Or there is other option, simpler one, which is, for example, if you shoot with filters and you don't have much color in the stars because you shoot with narrowband filters, say with hydrogen alpha or whatever. So you can go simple way and just don't process this picture at all. Just go to star processing and then go to star recomposition, and then window will appear which will show you 2 columns, and you can see background stretch parameters. So this is where you background, when you need to load your background picture, which in our case is already stretched, which is this one. Open, and it will open here, and then here you should open your stars, which is star mask. And you can see at once some stars appear, but they are just few of them and very faint, because this is mostly linear picture. So this is simpler way if you do not care about color of the stars, because maybe you don't care at all about them, or if the stars don't have natural colors because they are from narrowband or whatever, then you can just use this simpler method and adjust your stars in here instead of processing them separately. So I will show you just this quickly, how it works. So basically we will not use that because we already stretched our picture background separately, so we will not use that. But basically what you can do in very simple terms, just after you split your stars, you can start processing both files at once here. If you will go to advanced options, you can see now generalized hyperbolic transform also appeared here, so you could use this, but this is quite small and I would not recommend that, especially that I heard that if you will click apply, you can see now this composite is called unserved star recomposition result. And those are basically on screen 2 pictures but they are not blended yet. But somebody who I think knows about that does not recommend that method, because he said that if you click apply, then it will blend those pictures into one picture, stars. So after you start stretching your background, you will be also affecting stars. That's why, you know, in very simple cases, you could, after you split your stars, you could open this window immediately and stretch your background using that side and stretch your stars using this side. But, you know, for reasons I just mentioned, it's not recommended. Also, if you want to force this window to appear directly after splitting, after you go image processing, star processing, and Starnet star removal, if you, as I said, we check those two. If we check this recombine stars on completion, then after completion, separation is complete, it would automatically open those two pictures in this window for recombining, for star recomposition. But what would happen? Okay, the files would be loaded. I need to load them again because I closed the window. So, but this is not, I would not recommend that, because as I said, you can bake those with first apply. Somebody who I think who knows, who work a lot of Siril, he claims that it will bake those two files together, and then, you know, it's not that effective. So the best is just work on the background and work on the stars separately and then combine them. But as I said, if we not care about star colors, we can just open that. If we don't care about star colors, we don't need to, you know, process stars file separately. We can just load it here, and, you know, normally this is what will be open. Just use how it is, do nothing, just use this stretch to show more and more stars until you are satisfied. So you see more and more stretching, more and more stars start to appear, and they are brighter and brighter. If you want more star but not too oversaturated, again, you can go to this advanced and then slide to the bottom and then use this highlight protection point just to make sure that you are not oversaturating your stars. But you don't need symmetry point and stuff, don't bother with that for stars. Just use stretch factor. And you can see for stars, by default, he will choose for you human weighted luminance to preserve color stars, because stars are very easy to lose colors when you stretch. You can see we preserve some colors. You can see yellow stars start to appear. So if you don't care too much about star colors and stuff, just use that method, which is quite simple. And after you're happy, I don't like much stars, because more the stars is and less they are distracting from the nebulosity. So I personally will go for something more like this. But it's up to your taste. More stars, what also sometimes helps if you've got noisy pictures, if you've got more stars, they not only distract from details of the nebulosity, but also distract from noise. So if you want to mask some excessive noise, you can use more stars. But say, you know, I would be happy with that, just click apply here, and then you can close. And then you can see we've got unsafe star recomposition result. So we can save that if you want. We need to click save and do again. So we can say that this is, oops. Recomposed. And click save. And again, he will ask what kind of file it is. So say I want still this as a TIFF. So this is, you know, first method. More, if you want to be more precise with your stars, then again, I would recommend, and what I do most of the time, I will just process star separately, excuse me. And what I will do, I will just open my stars, and what I would use for stretching, I would only use here this arc signed hyperbolic transformation, which is to preserve color. And if you want to use that, this is quite simple. For fill stretch, just type 150, press enter, and you can see now all the stuff. By default, just if anything by default, you can see this human weight and luminance. This is to preserve color. It's by default here. And for second stretch, okay, we need to apply this stretch and then go again. And you should never do more than 2 stretches here. And for second stretch, you can just go up and up. Now it will be much more sensitive. Typically, I would not recommend, depends on the on the picture, but basically, in most cases, I would not recommend to go over 10. So I will use 10 here and just click apply. And now you can see how much, yellow stars popped up, and this you can see now even on this halo, it preserved this bluish hue, which was not that obvious before. So we greatly improved stars. So now we can save this file, and I will save it as star mask. Just say it's star mask stretched. Save, save. And then I will go again for recombining. So it's star processing, star recomposition, and it's the same here. We need to again load our stretch background in that side, and then we can use our star mask but stretched. It will be, you will see immediately, because I stretched it, it's a lot of stars. And now I can see that I stretched this probably too much for my liking. I would like to have less stars, but that's not a problem. We'll go to advanced. As I showed you before, for every modified and other function there is inverse. So we used on stars arc-sin transform, so now we'll go for inverse. And now what it will do, stretch factor will work as the stretch factor. So now I want less stars. So as you can see, those stars are smaller and fainter. So I will stretch them till I'm happy. But you can see that when I'm stretching also, the stars are a bit desaturating. So it's better, in that case, if I would be not happy, I would go back to star stretching and I would stretch them less. That's why I save those files separately. So I would go back to star mask, and I know I use 150 and 100, and it was too bright, so I would use 150 and 5, say, and load it here, save, load it here, and see if I like those stars better, because that method is better, because now I'm the stretching that I'm also desaturating stars. So, but I can just show you there is many ways you can use that. See, because it's already too long, I will just stop here. I will just stretch till I'm happy. But normally, for my liking, it's too much. I would go back and stretch less stars separately, just to preserve more color. But, to speed this up, I will stretch a bit more. Sorry, that way. That way. Okay, just say I'm happy with that. Apply, close. And again, we've got unsaved star, so we need to save it again. So I'll call this recomposed and add number 2. Now this is second attempt. This is good to do, just save your iterations, because you can always now open and see what looks better. Maybe first iteration was better, opened, yeah, that looks better, it's less star, maybe less colors, but, it's up to you. But, as long as you saving in your stages, it's easy to go one step back and process whatever you want. I think I prefer more colorful stars, so I will open second iteration, and basically we could finish this. As I said, this is quite a lot of noise here, So because, because there is not, I will not go beyond that, and I will show you just, I told you that this is not very good algorithm for denoising, but it's better than nothing, and because we are limiting ourselves to Siril tonight, so I will show you this. You can see if I zoom in, if you want to zoom in, I will remind you need to click Control key and use your mouse wheel to zoom in and zoom out. So you can see it's quite a lot of noise. So we will go to image processing, and then we will go to noise reduction. And then you've got some options here. If you will, this what we'll do, this will remove your hot pixels and stuff like that, salt and pepper noise, what is called. So you could keep this checked, and then it will apply just some basic denoise, which is not very effective, I can tell you. So it's good to apply secondary kind of noise reduction. This, this primary, it's, it will applies it always together with this cosmetic correction. If, sometimes you can use, you've got this cosmetic correction also, it was before, like here somewhere, which I show you here. So if you apply this before here, then you don't need to check there, but even if you apply there, doesn't need to, it will not affect you. It will just not find any hot pixels because they were previously removed. So you can always keep it checked, no problem. So first of all, you can just run how it is, no secondary noisy stage, but I know it will be quite bad. So what I trying all those stuff, I had the best result. It's still not very good, but best what can be achieved is the last one, which is called strength operate subtract inter, all short for SOS. You can see SOS. So you can always, try all those, because from picture to picture it may work better or worse. If you hover, it will tell you what it do. You can see if you've got picture which you've got a lot of noise, very, short exposure, not much data, then they recommend use this, because this will not, it will use another, it knows that it's a lot of noise and will use another method. You can read here that you will use not Gaussian, whatever noise, and you use Poisson, Gaussian, mix, whatever algorithms. So if you can go, you can try this as well. This sometimes this work good, sometimes not, but most often this work good for me. And the only stuff I was changing here, not to lose too much detail, because very often he will try to blur hell of the, and you will lose some detail. So most of the time I will leave by default, except for modulation. Modulation is how much, again, if you will go, it will tell you what it is. It will show you how much of the noise, how much force it will apply, just say how strong it will be. If you will go 100, this is like 100% one. I very often go 65. That means that, he will blend 1/3 of the noise back. So it will not blur that much detail. So it will blur a lot of noise, but it will better preserve some detail. So that's what I find the most useful. Again, this is my quite resource consuming, so if I will apply, it will take some time. You can see now what it's doing. Whoops. So it's denoising, and I can hear my fan in my processor is now going crazy because it's using full power of my processor. So again, if you've got older or slower computer, it will do this for you, but it may take, it may take some time, 5-10 minutes. If you've got, here should take maybe about 1 minute. You can see it did 3 already 2 iterations, now doing the last one and finish in 40 seconds. So we can now close it, and you can see, I'm not sure if you will see, I will go back just to, you can see that it is improvement, especially if you look at very dark features here. So I will go back, you can see it's much harsh, now it's smoother, but also you will lose some sharpness. So like here I'm not losing much sharpness, so in that case maybe I would go back and always you can go back. Now I'm done, and go again for this noise reduction, and I know that I can go slightly more, so you can just again iterate. Most of the time I'm using about 66, 67, but here I think I could use, you know, maybe 70, maybe 75. So if you can see you've got room that you know that you are not losing much detail. I didn't lose much detail here. You can increase that and clean apply and see. And again, if you don't like it, you can just always go here and just go back. Okay, so say I will apply this noise. I will not go again, just showing you your options. So now I redone this noise reduction. It's not perfect, but it's better than nothing. Okay, and so basically that's our picture. The last step would be, especially if you are not using any other software to finalize, you know, color balance, saturate and stuff, then what I would use here, if you're limited to Siril only, we will go with color saturation. And again, you've got what you can target here. You've got global, which means that when I increase saturation, it will affect the whole picture. You can see now, excuse me, that, you know, colors are boosted. You can click here to preview, and this shows where this saturation will apply. If you want preserve those blackness of space, then just go to that side. If you want to add you know, color, if you would be a lot of nebulosity here, which is very faint, but you know it should be red, then you can, you know, go that way. If you are in the middle, then it will add, you know, evenly to background and to the brightest part of pictures. It would add saturation evenly, but you know, like here I would like to preserve this blackness, so I would go probably something like that, so that if this is on the side from the middle, we are protecting shadows. If we are here, we are protecting highlights. So I want to protect shadows, and now I applied this global, but you know, at the first stages I would prefer not to global, I would prefer to target colors. So you can target colors here, and you've got, you know, very limited range, but you know, again, you can do something. So at the beginning, I can see this has more color than this, so I would just try to target red, which is pink, red, orange. So I would just go that. You can see this desaturated immediately, but this keeps saturation, so you can now go whatever you like. It's up to you, but I would not go too crazy on that because it will look artificial. Especially this algorithm, you know, this saturation algorithm, it doesn't look. It's better to do this, you know, in other software, but as I said, if you don't have any, use that. So probably this I would be happy. Apply. So we apply just reds now, then go again color saturation, and now I would apply global, but I still want to protect my shadows, and probably will go 20%, something like that. Maybe not, because now red is to red. Okay, or maybe I will go, or maybe not, red is to red. Okay, so I apply that, and I will go again, and I can also desaturate red, I think. Yeah, I can desaturate red back a bit. Okay, say I'm happy with that, you know, this is just demonstration, so you can keep faffing with that, whatever makes you happy, just apply and say that's okay. And basically one for things you can try to do is this contrast limited adaptive histogram equalization. What it does, you can see it already is in action. It will try to boost contrast of the picture, revealing even more details, but also you need to be careful because, you know, also will reveal some noise. So you've got some stuff, you know, most of the time it works okay with that, with those. You can switch before and after, you can see here. So, but you can, again, you can experiment with that. So this is threshold, you know, you can see, again, if you will hover, it will show you. Most of the time it will make picture more pop up, but also will make it brighter. So say, you know, and also will enhance your noise. I can see there is more noise, but say overall I'm happy, so I would apply that. But it make it a bit too bright for my liking. So you can use normal histogram transformation, which is the basic tool which was from the beginning, and you can use this to make it stretch it slightly, so get this midtones and start shifting back, and you can see it's now more what it was, and apply. But we've got, you know, even more contrast, local contrast. This is what this option did. It increased local contrast, so you can see even more contrast between dark and this faint stuff, and it's now pop up even more. You can see it's more contrast in the blackness here in the head, so it looks much nicer. And basically that's end of your options in Siril. Oh, and I'm exhausted, so I'm so happy that I finished, and probably you are that here is almost 10. Oh my god, I was aiming for an hour. But anyway, that's end of that, and I will shut up because I'll lose my voice in a minute.
I think that definitely deserves a round of applause.